sounds, including the sirens and whistles, come from during the trans-Earth coast. I believe ground control had asked for an explanation, saying it had come from the spacecraft. Secondly, I understand although low-angle lighting caused no problem walking around, there was a problem seeing obstacles in time when traveling at high speeds. I understand this might indicate the need for a flying machine rather than a rover for a long-distance lunar surface travel. Can you explain this?
We're guilty again. We sent the whistles and bells. We had a little tape recorder which we used to record our comments during the flight, in addition play music in the lonely hours. We thought we'd share that with the people in the control center. The sun angle was less a problem for the things you mentioned than the lunar curvature and the local roughness. It seemed to me as though it was like swimming in an ocean with 6-foot or 8-foot swells and waves. In that condition, you never can see very far away from where you are. And this was even exaggerated by the fact that the lunar curvature is so much more pronounced.
This is for Mr. Armstrong. Had you planned to take over semi-manual control, or was it only your descent toward the west crater that caused you to do that?
The series of control system configurations that were used during the terminal phase were in fact very close to what we would expect to use in the normal case, irrespective of the landing area that you found yourself in. However, we spent more time in the manual phase than we would have planned in order to find a suitable landing area.
Many of us and many other people in many places have speculated on the meaning of this first landing on another body in space. Would each of you give us your estimate of what is the meaning of this to all of us?
You want to try that? Well, I believe that what this country set out to do was something that was going to be done sooner or later, whether we set a specific goal or not. I believe that from the early space flights we demonstrated a potential to carry out this type of a mission, and again it was a question of time until this would be accomplished. I think the relative ease with which we were able to carry out our mission, which of course came after a very efficient and a logical sequence of flights, I think that this demonstrated that we were certainly on the right track when we took this commitment to go to the moon. I think that what this means is that many other problems perhaps can be solved in the same way by taking a commitment to solve them in a long time fashion. I think that we were timely in accepting this mission of going to the moon. It might be timely at this point to think in many other areas of other missions that could be accomplished. To me, there are near and far-term aspects to it. On the near term, I think it's a technical triumph for this country to have said what it was going to do a number of years ago, and then, by golly, do it, just like we said we were going to do it. Not just perhaps purely technical, but also a triumph for the nation's overall determination, will, economy, attention to detail, and 1,001 other factors that went into it. That's short term. I think long term, we find for the first time that man has the flexibility or the option of either walking this planet or some other planet, be it the moon or Mars or I don't know where. And I'm poorly equipped to evaluate where that may lead us to. I just see it as a beginning, not just this flight, but in this program, which has really been a very short piece of human history. An instant in history, the entire program. It's a beginning of a new age.
Neil, how much descent fuel did you have left when you actually shut down?
My own instruments would have indicated less than 30 seconds, probably something like 15 or 20 seconds. I think the analysis of made here on the ground indicates something more than that, probably greater than 30 seconds, 40 or 45. That's a good. That sounds like a short time, but it really is quite a lot.
Mr. Colonel Collins, you used a rather colorful expression when there seemed to be some problem with docking. Could you tell us precisely what was going on at that time? Were you docked, and then?
Are you referring to the lunar orbit docking when, after the two vehicles made contact, a yaw oscillation developed? This oscillation covered perhaps 15 degrees in yaw over a period of 1 or 2 seconds, and was not normal. It was nothing that any of us had expected. It was not a serious problem. It was all over in an additional 6 or 8 seconds. The sequence of events is that the two vehicles are held together initially by 3 capture latches, and then a gas bottle, when fired, initiates a retract cycle, which allows the two to be more rigidly connected by 12 strong latches around the periphery of the tunnel. This takes 6 or 8 seconds for this cycle between initial contact and the retract. And it was during this period of time that I did have a yaw oscillation, or we did. Neil and I both took manual corrective action to bring the two vehicles back in line, and while this was going on, the retract cycle was successfully taking place, and the latches fired and the problem was over.
2 questions. Colonel Aldrin, the pictures taken on the surface, your full portrait, shows distinct smudges of lunar soil on your knees. Did you fall down on the surface, or kneel? And then for Mr. Armstrong, during the last few minutes there, before the landing, when the program alarms were coming on, and etc., would you have gone ahead and landed had you not had ground support?
To my recollection, my knees did not touch the surface at any particular time. We did not feel that we should not do this. We felt that this would be quite a natural thing to do, to recover objects from the surface, but at the same time, we felt that we did not want to do this unless it was absolutely necessary. We found quite early in the EVA that the lunar surface material did tend to adhere considerably to any part of the clothing. It would get on the gloves and would stay there. When you would knock either your foot or your hand against something, you would tend to shed the outer surface of this material, but there remained considerable smudges. I don't know how that got on the knees. Neither of us fell down. We would have continued the landing so long as the trajectory seemed safe. And a landing is possible under these conditions, although with considerably less confidence than you have when you had.
For Mr. Armstrong and Colonel Aldrin, would you please give us a bit more detail about your feelings, your reactions, your emotions during that last several hundred feet of powered descent, especially when you discovered that you were headed for a crater full of boulders and had to change your landing spot?
Well, I'd first say that I expected that we would probably have to make some local adjustments to find a suitable landing area. I thought it was highly unlikely that we would be so fortunate as to come down in a very smooth area, and we planned on doing that. As it turned out, of course, we did considerably more maneuvering close to the surface than we had planned to do. And the terminal phase was absolutely chock full of my eyes looking out the window and Buzz looking at the computer and information inside the cockpit and feeding that to me. That was a full-time job.
My role during the latter 300, 200 feet is one of relaying as much information that I can that's available inside the cockpit in the form of altitude rate, and forward or lateral velocity. And it was my role of relaying this information to Neil so that he could devote most of his attention to looking out. What I was able to see in terms of the velocities and the altitudes appeared quite similar to the way we had carried out the last 100 or 200 feet in many of our simulations.
We're going to end here. We would appreciate it very much if you would remain seated so the crew could leave. They want to be at the luncheon at 1 o'clock, just slightly ahead of you. Thank you very much.